Okay, we're on number, what are we on? Number 51. So this might be our last grouping. May take two, depending upon how long these problems are. Actually, we just did 51, so we don't need to do that one. So next we're going to talk about, let's see, what 51, 54. Name all pairs of vertical angles in each figure. So let's draw the figure. We use black instead of red. So we have two intersecting lines. We have point T here. We have point S there. We have the intersection, which is Q. We have point P, and we have point R. So these two are vertical angles because they're opposite. The intersection, the opposite. You can kind of tell just looking at it from a magnitude standpoint. These are small, these are large. Okay. You can see also that they add up to 180 degrees. This plus that is 180. This plus that is 180. So we designate angles by, this is the middle letter, and then we can go either way. It doesn't matter. We can call this angle SQT or TQS. So angle SQT, which is this one, is a vertical angle. Its vertical angle is this one here, PQR. So that's one pair, and then you have the red pair here. So again, order doesn't matter. TQR, RTQ, so it's TQR. So that's this one, and then we do the other one, which is angle SQP. So those are, and if you did PQS and RQT, it's fine. Just looking at their answers, and they're slightly different because the order that they represented the angles. Okay, 57. Find the measure of each marked angle. Well, most of these are either equal or they're 180 degrees, or complements of each other, 90 degrees. So those are the three choices. So if we look at 57, we have two angles that are two angles added together create a straight angle, which is a line, and that's 180 degrees. So all we have to do in this case is say 10x plus 7 plus 7x plus 3 is equal to 180. And then we can solve for x. Once we know x, we can plug it back into the formula. So what we do is you look for common terms, which we have 10x and 7x. So that's, you add those together, you get 17x. Here we add the constants together. 7 plus 3 is 10. The right-hand side stays the same. We subtract 10 from both sides because we're doing the same thing to both sides. You can multiply by the same number, divide by the same number, add the same number, subtract the same number to both sides, and it doesn't change the equality because this is an equality and this is definitely an equality. And so when you do it, when you combine them, it's still an equality. So we would get 17 because 10 minus 10 is 0. 180 minus 10 is 170. So x is 170 divided by 17, which is 10. So x is 10. So now we can go back and we can plug them in. So let's say theta 1, which is, we'll say this is theta 1 and this is theta 2. Theta 1 is 10x plus 7, but we just found out that x is 10, so 10 times 10 plus 7, that's 100 plus 7, which is 107. And the angle of theta 2 is 7x plus 3, so we have 7 times x, which is 10, plus 3, so we get 70 plus 3, which is 73. If we add those together, we should get 180 to confirm that we did it correctly, which it is. So those are the two angles, 107 and 73 degrees. Okay, problem number 60. We have two vertical angles. because they're the ones that are opposite each other. In the previous problems, they were adjacent to each other. Now they're opposite each other. So because the vertical angles, they're equal to each other. So you don't add them up. You just say, what you say in this case is 5x minus 129 is equal to 2x minus 21. And now we solve for x. So you do that by getting x's by themselves are here and the constants by themselves are there. So to do that, we would add 129 to both sides. Okay, I'm going to put an equal sign here just to emphasize that we are doing the same thing. We have an equality here. It's like saying A is equal to A or U are U. Okay, so that gets, this will make this go to 0 when we add these two together. And here we subtract 2x. So we subtract 2x from both sides. So we got the same thing on either side. Obviously, that's the same thing. And we do that. And this goes to 0, of course. 5 minus 3. 5 minus 2 gives us 3. 2x minus 2x gives us 0, which is the purpose. And here we add those together and we get 108. So that becomes 3x is equal to 108 because we can drop out the zeros. And then we divide both sides by 3. And 108 divided by 3 is 36. Okay, so that's x, but that's not the answer. The answer is the angles. So we'll say again, theta 1 is the 5x minus 129. So we do 5 times 36 minus 129. And I'm actually going to get my calculator out for that. All these ones I'm doing in my head, you can use your calculator. You should try to do it in your head. It's good mental exercise. 5 times 36 minus 129 is 51. And the second angle is the right-hand side of the equation, which is 2x minus 21. So we put 2 times 36 minus 21. So 2 times 36 minus 21 should be 51. Okay. So you might say, well, why did you even need to do that? Well, you're doing it to confirm that you got the right answer. You could have just done the first part and said, oh, they're equal to each other, but you could have made a mistake. Okay, number 63. So 63 are supplementary. Let's do 64. Because that's a complementary one. We haven't done one of those. So complementary angles add up to 90 degrees. So just like the first problem that we did, which was 57, we're going to take 5x minus 1, call that theta 1. We're going to add that to the other angle, which is 2x, which we'll call theta 2. And because they're shown to add up to 90 degrees because we see a right angle, set it equal to 90. So again, we combine like terms. So we get 7x minus 1 is equal to 90. You add 1 to both sides. That gives the variable by itself. And here we get 91. And so x is going to be 91 divided by 7. And that's going to be, okay, how do you do this in your head? Well, you know that if you had 70, you'd get 10. Okay, so 70, and then what have you got left over? 21. Okay, so that's 21 divided by 7 is 3. So we know the answer is 13. And again, that's not the answer. The answer is what are the angles. So theta 1 is 5x minus 1. So we do 5 times x, which is 13, minus 1, which is, here we have 5 times 10 is 50, plus 5 times 3 is 15, so that's 50 plus 15, which would be 65, minus 1, give us 64. Theta 2 is just 2 times x. So we have 2 times 13, which is 26. And we confirm that we did the problem correctly by adding these two together to make sure they add up to be 90 degrees, which they do. So that's kind of a check. So the answers are 64 and 26. Okay, so what problem that was 64, which I need to make a note of. So I assign you the right problem. Okay. So I'm trying to decide whether to just keep going. Yeah, let's just keep going. We'll have one less video. So next one is 69. Assume that lines M and N are parallel and find the measure of each marked angle. So I'm going to go ahead and draw this. So what we have is we have a line. We have two transversals. Actually, these are the two parallel lines, and this is the transversal. And obviously, you can tell which ones are equal to each other because the vertical angles are equal to each other. And also, the bigger angles are equal to each other. So this is equal to that, this is equal to that, this is equal to that. Those are the big angles. So theirs are equal to each other in all four cases. And then the smaller angles are also equal to each other. So in this case, we have this angle is 10x plus 11. And this angle is 15x minus 54. So the question are, what are the two angles? Well, they're going to be equal to each other because, again, notice this is more than 90. This one's more than 90. This one's less than 90. This one's less than 90. So these are equal to each other. So all I have to do is set them equal to each other. Again, we're working problem number 69. So you say 10x plus 11 is equal to 15x minus 54. What we're going to do is I'm going to, let's see, add 54 to both sides. And I'm going to subtract 10x from both sides. Now the reason I did that is just so this would be positive. I wouldn't have to divide by a negative number ultimately. So again, these are exactly the same on both sides. So this is equivalent. These are equivalent by definition of the angles. And so we just add the terms. So you get 0x, which is just 0. 11 plus 54 is 65. And then 15x minus 10x is 5x. This goes to 0, so we can drop the 0 things. So we just end up with 65 is equal to 5x. 5x is equal to 65. That's one of the properties that you can switch sides. So x is just 65 divided by 5, which is going to be, well, let's think about this. 50 divided by 5 is 10. You got 15 left over. 50 minus, so that's 15 divided by 5 is 3. So it's going to be 10 plus 3. So the answer is 13. Now that's not the angle. That's, again, we have to go back up and use both of these equations to confirm that we did it correctly. So I think I'm going to add a page and show both the pages here. So theta 1, we're going to call this angle 10x plus 11. So we have 10 times 13 plus 11, which is 130 plus 11, which is 141. Theta 2 is 15x minus 54. So we have 15 times 13, which is not so simple. So you can use your calculator, but I'm going to show you how I do it. I take 10. So in this 13, I take 10 times 150. 10 times 15, which would be 150. And then I do 3 times 15, which would be 45. So I take 150 plus 45, which is 195. And I subtract 54, and that is 141. So these are the same. and that's the answer. Now, just to let you know, like 66, the angles would be equal to each other. So theta 1 is equal to theta 2. In 66, or 67, 66, 67, if you look at that, the angles are equal to each other also, because they're both greater than 90 degrees. And then the last one is 68. If you look at those two angles, they're what they call alternate, or what the heck is it called? They're same side. I forgot what the heck they're called. Something cheat here. There's interior angles on the same side of the transversal. Okay, not what I thought you would call it, but anyway. So in that case, those two angles add up to 180 degrees. So when you have parallel lines in a transversal, the angles are either equal to each other or they add up to 180 degrees. And when you draw it as such, you always know which is the bigger angle, which is the smaller angle. So the big angle plus the small angle is 180. The big angle is equal to the big angle. The small angle is equal to the small angle. Okay, problem number 72. Solve each problem. The supplement of an angle added to the complement of an angle gives 210 degrees. What is the measure of the angle? So what is a supplement? A supplement is equal to 180 minus theta. The complement is equal to 90 minus theta. So it says the supplement of an angle, which is that, 180 minus theta, added to the complement, which would be 90 minus theta, is equal to 210. So that's the word problem. The supplement plus the complement is 210. So now we just need to solve for theta. So we have the two constants together. We get 270. We have the two thetas together. We get negative 2 theta. And we get 210 on the right-hand side. So what we're going to do is we are going to subtract 270 from both sides. We only have theta on one side, so we don't need to do anything there. Let's put an equal sign. So these go to 0, and you end up with negative 2 theta there. And this is 70, so 210 minus 270 is negative 60. And then, so that's negative 2 theta is equal to negative 60. So theta is equal to negative 60 divided by negative 2. So theta is equal to 30 degrees. So that is the answer, 30 degrees. So you can see 180 minus 30 is 150. 90 minus 30 is 60. 150 plus 60 is 210. And the final problem, 75 degrees. Use a sketch to find the measure of each numbered angle. Assume that M is parallel to N. So the best way to do this is for me to draw it, and then we can look at it. So what we have is two parallel lines and two transversals. And there's a special thing about the transversals. They meet at that point. And so we have 8, 6, 7, 120, 9, 10, 4, 5, 1, 2, 3, and 55 degrees. So the best thing to do is start over here, because if you started here, there's nothing that tells you what these things are. So I'm going to put 2 pages on so we can talk about this. So, and what I'll do is I'm going to write it in a different color here as we go along. Okay, these these two lines, these two angles add up to 180 degrees. So this is equal to 60. 120 plus 60 is 180. These two are vertical angles, so this one's the same as that, and this one's the same as that. Okay, now, what else do we know? Well, here we have two parallel lines and a transversal. This angle 3 here is the same as this angle right there. So that's equal to 60 degrees. Now we have a straight line here. So this plus that has to equal 180. So 2 is going to be 180 minus 60 minus 55, which is equal to, let's use a calculator, just make it easy on my brain right now, minus 60 minus 55. So we get 65. So that's equal to 65. Okay, now these are all vertical angles. So we know 4 is 65. We know 3 is 60 because that's the opposite one there. And this one is 55. And now we can go up this direction. So here are two parallel lines, transversal. This is the interior angle. This is the same, this small angle here is going to be the same as that small angle. So that's 55 degrees. And these are two intersecting lines, and these are opposite each other. So this is also 55 degrees. So what I should see is 1 is 55, 2 is 65, 3 is 60. I'm just checking my answers here. 4 is 65, 60, 120, 60, 60, 55, 55. Okay, so anyway, that is the correct answer. So let me review what we did. We knew that these two had to add up to 180 because this is a straight line. We also knew this one has to be 120 because these are two vertical lines. They're two vertical angles because they have two intersecting lines. So this is 120. And likewise, this is 8 and 7 are vertical angles, so this is 60. Then we came down here. Here's the transversal. Here are the two parallel lines. So we took angle 8, which is this one. You come down here, and the corresponding angle with the same line and the parallel transversal is this angle. So that's 60. So that one equals that one. Then we said, okay, this plus this plus this has to equal 180 because this is a straight line. So we could solve for this by taking 180 and subtracting these two. And we ended up with 65. And all the other ones are easy because these are all vertical angles with the opposite one. So this angle is opposite that one, so that was 55. This one was opposite this one, so that's 65. And this one's opposite that, so that's 60. And then we go up here and we say, okay, which angle down here corresponds? Well, here's the transversal, here's the line, here's the parallel line, here's the transversal. So this angle is the same one. So then I could move that up here to 55, and then I could say that. Now they don't ask us for it, but if we wanted to know what these are, well, those would be 180 minus 55, which would be, so take 180 minus 55. These would actually be 125 degrees here and 125 degrees there because they're vertical angles. Both of these add up to 180. These add up to 180. These add up to 180. So you can see it all kind of works symmetrically. Okay, so that's it.